Hello everyone, today we're gonna do paper 2. We're gonna be doing some paper 2 questions, like a mix of some. I should have like chapters in the description or something so you can like skip around the video and like see specific questions if you want. First question, a solution to a problem may be represented using pseudocode, flowcharts, or this is part of methods to design and construct a solution, and it's mostly going to be visual. So we have three ways: pseudocode, flowchart, where we know that. The third way would be structured diagrams. So just hold up. Yep, there you go. There you go. That's one mark. Okay, next. Tick a one box to complete the sentence. And we're finding a selection statement. Selection is when there's like different routes in the program. Like for example, if a user performs one action, something will happen. If a user performs another, something else would happen. So there's two types of selections. There's going to be if statements and case statements, and there's only if statement here, so we will tick that. In this question, it's a mix and match question. So they're asking about test data types. Abnormal data type is okay, so you're given a range. Abnormal is when it's outside that range. Boundary is when it's like it's within the range, but it's at like the very edge. Usually boundary there's two numbers. There's one at the edge and just right outside the edge. So let's say it's a range ending in 100. The boundary test data would be like 100 and 101. Extreme is when it's okay, yeah, it's on the edge. That's it. So in that same scenario, it would be 100. Normal is within the range. So let's do this. Value that is accepted, that would be the normal. Why is this red? Okay, a value that is the highest or lowest and it's accepted, and a value that is the highest and lowest but it's rejected. That would be boundary. A value that is the highest or lowest. This doesn't fit any of our description here because extreme is it's at the corner but it's not rejected. And then abnormal is a value that is supposed to be rejected, so that would be this. And then we finally have this, which is that. Yeah, cool. Okay, and here they gave you a range of 5 to 10 inclusive. So abnormal is a value that is rejected, so it would be anything outside the range. So like, for example, 31. Boundary is at the very corner of the edge, including one outside the edge. So for example, it could be 4 and 5, or it could be 10 and 11. You just have to write one set. Okay, an extreme would be one that is in the edge, so you could take 4 or 5. It appears I made a mistake. For extreme, usually you just want to take they'll give you a range from and to. So the trick here is just take the number they give you. So you can either take 5 or 10. Normal is within the range, so just 6, I guess. Okay, we're gonna do a pseudocode question here. In this question, they give us an array, which is they tell us the length, which is 1 to 50, and they tell us 50 numbers are already in that array. And so we're supposed to write an algorithm that allows us to input a number, which is gonna follow this variable, and we have to use linear search to test if that number is stored in the array. If number is found, then we have to output the position in the array of the array. If the output is not found, then if the location is not found, we have to output not found. So we want to usually try and like fulfill these tasks. So input a number, you just write it down. There you go. And they're asking you to use a linear search, so let's do some searching. Okay, usually when they ask you to search, it's usually going to be using a loop, and there are 3 loops. We have the for loop, the while loop, and the repeat loop. Usually if they give you an array and you already know the length of the array, then you can use the for loop. So I'm going to use the for loop here. Jesus. I hate this fucking software. Okay, so we're gonna write for, and then your index, you can call it whatever, but I'll call it index, which will be, this is an arrow sign, 1 to 50. Yep, that's it. That's your start of the for loop. And now we have to try and find it. Now your index in this loop will, what can I, your index, now in this loop, your index will cycle from 1 to 50. And so if you know how an array works, it's any number in this will be that slot of the array. So we're gonna do, okay, we're supposed to linear search. So if my number equals the index, no wait, the array, which is, they gave us the name of the array, which is values. And then for your index, you put your index there. If it's equal, you will say, then output would be found. Okay, since let's assume we found it. Okay, if the number I input equals to the value in the array, then we'll say found equals true. Make sure when you put a variable in your loop and you want to use it outside, make sure you call the variable outside the loop so you can use it anytime outside the loop. If you call it inside, you can only use it in the loop. This is what we call a local variable, which means you can only use it in the loop that you created. But if we put it outside, it will become a global variable, which means we can use it anywhere in the code, basically. Let's just put it as false for now. Okay, I don't have anything left for this one, so let's just end it here. Right, next index. Okay, what this will do will basically cycle the whole loop again, but in the next index. So how this loop works is it'll go from 1. Okay, 1 will replace index. So if the number input equals to value slot 1, let's assume it doesn't find it, it'll cycle to the next index, which will be 2. Then repeat everything, next index 3. Repeat everything, next index until 50. Okay, now we're gonna say if found equals true, then, oh yeah, also when you use an if statement, make sure your code next in line of then should be indented. So I forgot to do that, so make sure you do that. Okay, so let's say if it's found, we have to output the position of array, which we already stored as location. Oh, we didn't store it. Oh shit. Okay, we're supposed to store the position in the position of the array that is our number. So in the loop, we will just say location equals index. Nope, not equal, but arrow. So yeah, we'll assign the location, the variable of location to the index if we found it. And for the same reason as like the global local variable, you wanna call it outside of the code first. It's best to always like assign your variable at the very start of the code. Okay, so next we will do, assuming that we found it, we will output. So they ask us the position of array. So we'll output the position of array is, and then you want to type your location, which is the variable. Cool. Now, that's cool, but what if we didn't find it? What if found equals false? We'll put else, and we'll have to output not found. And there you go, that's the code right there. This is an error correction question. So Before we do this, there are two types of errors that are very common. One is syntax errors. That means they like misspelled a they misspelled like they misspelled anything. And then the next one is logic error, which means the code just doesn't make sense. So let's get straight into it. Oh, I just want to say, also before we do this, these types of questions, Cambridge, they love to like screw up an ending of a loop. So every time they use a loop or an if statement, keep an eye out for the like how they end it, because they always type it wrong. I swear to God. An algorithm has been written in pseudocode to calculate the profit. So we're supposed to calculate profit when item is sold. Let's highlight that so we know what we're trying to do. Value for cost price and selling price are input. Okay, so that means the user has to input the cost and the selling price, which is then calculated with this formula and the output. And then they'll output the profit. Input of 0 stops the algorithm. So if the user puts in 0, it will just stop. Okay, let's see if this is correct. Repeat. Output, enter cost price. Cost, correct. Oh, look at this. Output, cost price. Input, cost, correct. Output, enter selling price. Output, sell. This is supposed to be an input because they want to input selling price. But it's output. So that's our first mistake right there. Not ours, but to Cambridge. So that's supposed to be input, sell. Okay, and then I am assuming this is the input of 0 will stop the program. So if cost not equal to 0 or sell not equal to 0, if cost not equal to 0 or sell not equal to 0. Look at this. Input of 0 for either values, so both. It has to be both of them. But here it's saying it can be any of them. It can be just one. So this is not supposed to be an or, it's supposed to be an and. So that's our second mistake. It's supposed to be, what the fuck? It's supposed to be, not input. It's supposed to be if cost and there you go. So let's say if we didn't put any zeros in, then it will calculate the profit, which is sell minus cost, correct? Output profit is profit, correct? Next, oh, we didn't use a for loop. We used an if statement. It's supposed to be end if right here. So that's our last error. It's supposed to be an end if. There you go. Cool. There's a follow-up question which asks you how you can improve it by writing a pseudocode to reject the input values less than 0 for variables cost and sell. In the original code, it's just 0. If you type like a negative number, it'll still calculate it. But what they want you to do here is to reject anything less than 0. So this is during the input stage. So let's just do it right now. Oh yeah, you don't have to rewrite the entire code. Just write like what is needed. Let's do a repeat loop, which is going to be a post condition loop. That means the loop will only end after it has been run. So let's do cost sign. You can sign again. Input cost. Oh, before that we want to say output first. Output and the cost price. And then the user will input cost, and we will end our until loop here, our repeat loop. So until, okay, so they'll keep repeating it until it's more than 0. Because if it's less than 0, it'll just repeat and tell them to keep inputting something that isn't a 0 or less than 0. So until cost becomes more than 0, more than or equals 0. Yeah, and then you just want to do the same. It's just the same thing for the other one, so just copy paste it. Ironically, I'm not copy pasting. And boom, that's it. 3 marks right there. Okay, the next question asks you to describe 2 other validation checks that could be used in this algorithm. So let's think of all the validation checks that we have. Okay, there's a range check, which sees if the number is within a range, but we don't have anything to do with a range here, so let's not do that. We have a length check, which is supposed to find like the length of the value, not the number, the length, and it's mostly used for like passwords, so that's wrong. We have a type check, which ensures that a value is a certain data type. Now this is actually what we need, because in our current code, the user could input like a letter, right, and that's an error, so we want to make sure that they can't do that, so we'll do a type check. And the type check is supposed to check if value is an integer. Okay, and then the next check is going to be a format check, which it's going to be like, for example, like an email address. That's a format. We're trying to do money, which is just integer. There's no format. And then lastly, we have presence check, which checks if there is a value in the variable. Obviously, we want a value inputted, because if nothing's inputted, then it's just going to calculate something, but that's going to be nothing. So we want to put a presence check, which is to check if input has been inputted. No, if value has been inputted. There you go. In next question, they're asking you, analysis is one stage of the program development life cycle, and they're asking you to state another one. And in the program development life cycle, we know there is analysis, we know there's analysis, analysis. We know there's analysis, and there is design, coding, and testing. So you can write any one of them. Let's just write coding. Okay, describe the analysis stage of the program lifecycle, and this is 3 marks, so 3 points. The very first definition you learn in analysis is supposed to be abstraction, which is like when you identify the problems, the key problems, and then remove any like unnecessary detail, so that it becomes like way easier to solve. So you just like narrow it down. So we write abstraction. Extraction is used to remove unnecessary there you go, that's 1 mark. And one way to one form of abstraction is decomposition. It's when you break down like a problem into much smaller subgroups, you know. So we'll say decomposition is used to break down problems into smaller groups, smaller, much easier parts to solve. One way of decomposition is using a flowchart, and flowchart usually uses input, output, and process. So you can say breaks problem into input, processes, and output. There you go, 3 marks. Okay, let's just do this one. Outline one type of verification check that could be used when you input data. This is like, for example, one example is when you enter your password. They always ask you to like double type your password, so that would be called double entry check. And the way they check it is they check if the first set of data is the same as the second set of data. If it doesn't match, okay, and if it doesn't match, it will output an error, and then it will request you to type again. There you go. Okay, over here we have a Boolean Logic question. This should be pretty easy. Okay, Cambridge will usually ask you like in two ways. It's gonna be always either this way, like one group and then one logic gate and then another group. But there's like recently I checked like a paper and they ask it like differently. Like it's actually slightly harder, but I think it's recent, so I haven't seen it yet. But let's just like, but I think they also use this format. So let's do this format for now. Okay, usually my trick here is the middle gate, you can always just put it at the end. So NAND gate is just gonna be like this. Boom, NAND gate. And then now you can focus on the groups. So the first group is not P. So we'll do a not P or Q. We need an OR gate, which is like this. Connect them. And there you go, that's your first group, which is gonna connect to a NAND gate. Boom, done. Q's or R. So Q, when you have repeated values, you can always just take like a wire from it, so like that. But make sure if they ask you for P, you take it before the NOT gate. So that take it before the NOT gate, because otherwise if you take it after, it will become not P. If you take it before, it will become just P. So we'll put SAW, which is just an OR gate but with like two tails. That look kinda ugly. Let me try. Yeah, sure. Connect them both and then there you go, done. Cool. Fuck. Okay, and then we have to do a truth table now. Here you just want to focus on the group, so not P. If you want to be super careful, I recommend you do it like step by step. So not P. Everything in this value is just going to be opposite, so just 1, 1, 1, 1, and then the rest are zeros. Cool. And then the next group is going to be Q's or R. You can also just like assign letters to these, so let's just assign letter M. It makes it a little tidier. I also don't think the examiner cares about your working, they just care about the answer, so yeah. Q's or R. So that means exclusively OR. There cannot be two ones like this, otherwise it would be a 0. There can only be one 1. Boom, done, okay. And then finally you do the NAND gate. What I usually do is just skip to the X, because the NAND gate would be your final calculation, so that would be your final answer. So just treat this as your NAND gate. So you just take these two numbers. Oh wait, oh my god, I didn't do the first group. I only did the not P. Okay, let's do the first group real quick before we get carried away. Not P or Q. So this or Q. Now since it's a normal OR statement, as long as there's a 1, it will become a 1. Okay, now you do a NAND gate, so it's N, NAN, M, NAN, N, yeah. So it's these two NAND. NAND basically means a NAND gate is usually just if the both inputs are 1, it's 0. That's it. So so here there's a 0 and a 1, so that's a 1. Now these two are 1, so that's a 0, 0, 1, 1, 0, 0, 1. There you go. That's 4 marks for you right there. That's 8 marks total for Boolean logic. Isn't that crazy? Literally 3 marks. There you go. Okay, here question. Okay, here we have this question right here, database question. We have a table called booking28, and it stores some stuff. Cool. First question: state the number of fields and records in the database. Okay, field is the number of columns. So like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That's the answer, 11. Records is the number of rows there. We don't count this part right here. We only start from the actual data. And okay, Cambridge when they give you like a table, they usually have like a ID for the table, and they will have ID most likely will have like a this ascending order for the number. So you can see like 1, 2, 3, 4, and you might like think, oh, I'll just get like the last number and that's the answer. That's not true. Sometimes they'll trick you and they'll like miss some numbers. So you actually want to like count. That's the only way. Okay, in this case, they like mix it up, you know, like there's like more than one numerical. There's like 100, then there's 200, then there's 300. So they'll try and trick you sometime. So let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, the answer is 15. Cool. Okay, question B. State the reason why the type field would not be usable as a primary key. Okay, primary key is a unique identifier. They like 80% of the time will ask you why it's a primary key, and you just say it's a unique identifier. But I'm surprised in this case they don't do that. That's pretty rare. Anyways, type field. Why is type field? Why is this not a primary key? Well, simple. We just say the opposite. It's not a unique identifier. Or you can say like it doesn't have a unique data. That works. Question C, data types. And they ask you name one field. Okay, so they give you a set of data types and you have to find field that uses the data types. Once again, I'm surprised because usually it's the other way around. They give you the field and then you have to fill in the data type. This paper is it's showing off. Okay, let's start off. Field alphanumeric. Alphanumeric is basically just text or like string. So it could be like letters and numbers combined. And in this case, it could be room no, or it could be type. But I'm gonna go room no because it has numbers and letters, so that could be more safe. Okay, Boolean. Well, I mean, it is pretty obvious, isn't it? Boolean is basically when there's like a true or false, basically. But something that you may not know is Boolean can also be just like a letter. It could only if there's like two letters. So in this case, there's only two letters, T and F. That works as Boolean. And since there's like 6 of them, 7 of them, just put one. So I'll put Monday. Okay, real numbers. Real numbers is any numerical value with decimals. And so it's right here, rate. Integers is, number, so guessed. Okay, last but not least, they give us a SQL statement and we have to follow it. Usually they will ask you to fill in the blanks, but this time they make you do the output, which, yeah, okay. Okay, so they want you to output, so select whatever these are. When they say select, anything that comes out to select is what you're gonna have to display. So room no, type, guess, and rate. Room no, type, guessed, and rate. So basically just the first four. Let's see what they want. Okay, from booking 28, that's the table. This is standard. Okay, this is what they really want. Like, what's the filter? Where Monday is not T. So Monday is not T. So that means we have to look for Mondays that only have F. So it's this right here. It's this line, it's this line, this line, this, and that. So what you want to do is just copy everything down, kind of like, I'll just write the first line first. Wait, 100 for S. You just leave a space in between. You don't have to leave like a comma or anything. A space will suffice. 1 and then 72.5. And that's the first line you have to do, and then you have to do the rest. I'm not gonna do it because I don't feel like it. Okay, the last question we're gonna do is a flowchart. Could be kind of scary. The way they mark you in this question is a bit. I don't really get it, you know. But I think it's like for every column you get right, that's 1 mark. So yeah, something like that. Okay, basically you just wanna follow the flowchart. Is pretty simple. Very straightforward. So it's to find average size of groups, whatever, I don't care. 7. Okay, this is your number to input. So if they ask you to input, put 7. Start. Okay, they assigned some stuff to the variables. So every time they assign, you have to like put in a table. So number group is assigned as 0, so put that. And total is also 0, so put that as well. And then next, okay, input group size. This is where we input 7. And we follow through. Is group size equals 0? Nope, it's 7. So we follow no. Number group is assigned as number group plus 1. This, every time you see something like this, like when they use a variable and then it's the same variable plus 1, that's usually a counter. So it's, 0, 0 plus 1, that's equals to 1. So we'll write 1 right there. Okay, and they assign total to total plus group size. So total would be 0, group size would be 7. So it's 0 plus 7 equals 7. Simple math. And then you just repeat the loop. Input group size. So you put 10. Let's see. Is group size equals to 0? Nope. Okay, no, it's not. Then number group plus 1. You're just gonna repeat. It's very repetitive. That's why they don't give you like a lot of marks. It looks scary, but it's straightforward. Total is group size. Okay, total, which is currently 7, plus group size, which is currently 10, so 17. And then you just repeat 2. It's so predictable, you can almost like, I can just automatically do it without like looking at the question. Like I'm just doing it, you know? It's pretty simple, nothing that hard. I hope I don't make a math mistake here, that would ruin my flow. Tree. Please tell me if I'm too fast for you in the comments. Hopefully not. Okay, we input that. Should be 6. This will be 39. And then as you can see, the next data we have to input in the list is 0. So let's follow with this again. Input group size. We're gonna put in 0. Okay, is group size equals 0? Well, it is finally, so we'll say yes. Average is assigned as div total number groups. Okay, div is it's like a operator, like one of those math symbols, but in pseudocode. Basically, it just means quotient. So what you do is like, let's say you want 22 div 5, you will get 4. So it's basically like you divide it, but not the remainder, if that makes sense. Like just divide what is possible in that number. So here, for example, if I wanted like 22 div 5, okay, so you just basically like divide the number of multiple times you can with 5. So 5, you can only get up to 20 before reaching 25, but it's only 22, so the answer you would get is 20, and so the division would be equals 4, because 5 times 4 equals 20. And so in this question, they ask you total div by number groups. So our total is 39 divided by number groups, which is 6. So you just do what I said, which okay, let me think. 6 times 5 is 30, 6 times 6 is 36, and that's the farthest we can go because the next number is 42, I think. So we'll put 36. Oh wait, it's not 36. That's what you get. Okay, so it's right. Like I said, it takes like 5 times 4 to 20. So 6 times 6. So you just put 6. It's not 36. That's yeah. Okay, and then output is the next in line is output. Average group size is average. So you just basically write what they say word for word. Don't write something else, otherwise you will get something wrong. Average is 6, so that's it. That's flowchart right there. Oh, usually when they write output, right? If they leave a space, please leave a space as well. If they don't, you don't have to. Let's say they don't leave a space, it would just look like this. Yeah. So that's flowchart right there. Pretty easy, simple, not bad. Okay, we have this question right here which asks, program has been written and maintained by another programmer. Explain how program can be written to make sure it is easily maintained. Wow. To make sure it is easily maintained by other programmers. So basically they're asking you ways to make a program like maintainable. One of them is the use of comments. You can comment by, in pseudocode, comments starts with like a backslash, kind of like that. So you can say use comments to like explain what the hell you're doing. So explain the purpose of your code. And the next you can, another one is when you write variables, the variables can be anything, but you usually want to make it, you want to name it something that's like meaningful, something that like is like self-explanatory basically. Like if I said my phone and I give you another variable, and I tell you one of them is my phone, which one do you think it is? It's obviously going to be this one. So you want to say variables must be named meaningfully. Why is it named meaningfully? Is to once again like identify the purpose of it, purpose of the variable. There you go. Usually in code, you may like end up repeating some of your like calculations. Let's say you want to measure the length of a shirt, but you have 1,000 shirt to measure. What you want to do is you can either use a function or a procedure to like you put that measurement, that code of measurement inside the procedure or function, and then you every time you need it, you just call it and then it'll do the calculation. You don't have to write the same code 1,000 times. So say use procedure or function to avoid, repeating the code. Yeah, okay. And then last but not least, when you code, try and like space it out. It's kind of like in English, you use paragraphs to space out your writing, and you use like every time you start a paragraph, you indent your paragraph. You leave like a little space. Do the same for coding. So use indentation, and like don't make the code cramp, and like leave some space. Code chunks, is that what it's called? There's something, code blocks, there you go. I think that's the word for it, but I'm not gonna say it because it could be wrong. You want to do that so it's like to make sure it's readable or like easy to understand. Readable or to understand. There you go. Nice. I was gonna do like a few more questions, but it's getting really late, and I want to post this right now. So I think I'll make like a part two. I'll do better. I'll do a better job because I'm just rushing this video, so you can like see how I do it. Yeah. Okay. Yeah, that's about it. See ya.